afternoon, everyone. We have heard, an interesting topic about natural ventilation of tall buildings and how can we achieve it. How we design a microclimate is important to achieve, a natural ventilation in tall buildings. The presentation which I have, a microclimate study in a hot and humid climate, is based on Vipac's projects on a region which has an extended scope in microclimate design. But what I have here is part of it, that how the climate is important in the design of microclimate, the bigger picture of the climate, and our street orientation, our street design, how they play a role, and the density of the city, the distribution of high-rise towers, and how can we minimize the dust loads, and the heat island effect, shading, albedo, and vegetation. I will discuss all this, and I will have, a summary. In a particular region, a deviation of climate experience from place to place, it will, in a few kilometers, it will form a climate pattern, a small-scale climate pattern. This small-scale climate pattern, what we call it microclimate. And this microclimate will have an interaction with the bigger picture of the climate. So what when I'm thinking about microclimate in a temperate region, it is markedly different when I'm talking microclimate in a humid and hot climate. And when we are designing, a city, which is, has a characteristics of a certain climate, the microclimate, in a hot and humid climate, understanding the bigger picture of the climate of the region is important for us in our decision making in the design of the city. What we are looking, to optimize, our optimization of our design in the city planning, in what I said in street orientation and all that, will place the performance, what we are getting from the city. And what we are looking, what is our objective in here is to achieve comfort. What kind of comfort are we looking? Is adaptive comfort we are looking. One of the questions which is raised is, as everybody is feeling a little bit colder, but if in this hot climate, if we are adaptive comfort we are looking, we have to look a little bit higher temperature. So what kind of comfort we can achieve? How can we minimize the pollution? And actually the microclimate design, it also includes noise and energy, minimizing the energy consumption of the city, helping a green city design. So the main, what we are looking is street width and orientation, mass density, massing of the buildings, and how they are progressing, the dust and the heat island effect, shading, vegetation, and I'll go through in detail in each one of them. Well, what is important? The first important is the climate. We have to understand the climate of the region. And this plots, it tells us a lot of story about the climate. This is about in Dubai, 20 to 26 August 2006. The top one, it gives us the temperature. This one is the dry bulb temperature, and the bottom one is the wet bulb temperature. And in a week time, that is Monday, Tuesday, Wednesday, and we can, in 24 hours, it starts from 0 and it progresses to the middle of the day. So at midnight, the temperature is low, and when the sun rises, the temperature starts getting up, and at the middle of the day, it becomes high, and then it goes down. And each day it has a similar kind of pattern. And when we are looking, the wet bulb temperature, it has just the reverse kind of pattern. But you can see some of the times there is a clause between wet bulb and dry bulb temperature. When we have that, that's what you experienced this morning when you wake up, you have seen the fogs. And when you have a very close thing, then you will see that experience. Even the temperature is around 20 degrees centigrade. So understanding this will help us in our design of the city. And when we are, what other characteristic we can see is the wind speed. The wind speed, you can see that it starts low and gets up, and then it dips, and then starts again up. It gets up, and then it starts getting down. And similar kind of characteristics in every day is repeating. The bottom one is the wind direction. The wind direction is in the morning, in midnight in the morning, it is coming from the south, and then it changes direction, it jumps, and in the afternoon, and starts on the northwest. So every day it has the same similar pattern. You can relate that the change in direction is related to the dip which we can see in the wind speed. So there's some discontinuity which we see here is related in the change of direction. So there is a land breeze changing to a sea breeze. So understanding this, how we are orienting, where we have to open the streets is important in understanding. So the whole story of the climate, we can see it here. But in actual, in the full analysis, we go to a lot of parametrical study. This one, it shows us the radiation in July and August, which you can see it's a similar kind of trends they have in both months. It's around 650 milliwatt hour per square centimeter. This is what we are getting in our roofs and in our facades, and what kind of materials we are using, whether we are covering it with vegetation or we are having low albedo materials. That will play in the climate of the city, what is the heat of the city which will have. Well, in our study, we used different kind of methods. What we used is a wind tunnel study, a numerical study, a safety study, and a full scale, some measurements. So in a wind tunnel, we model them in scale and use a flow visualization and see what will happen when we have a channeling flow, when we align the prevailing wind direction with the street axis, and we get really a channeling flow. Is that a good thing? Maybe yes, maybe no. Because when you have a big block, each block, when the wind is coming straight, you'll have high wind, which is channeling, but you are blocking a lot of wind. So if you have the long axis of the block is perpendicular to the prevailing wind, that is not advisable. But what will happen when we have a wind which is oblique to some angle? Then we will have a wind which is distributed in all the streets. So the strength may not be as same magnitude as the channeling flow, but you will have a lot of winds movement in all. And what we are looking, the thinking what we have in here is quite different, in hot and humid climate is quite different when somebody wants to design in a cold climate. If somebody wants to design, a city in Alberta, Canada, it's very cold. You don't want to have the wind. But in hot climate, you want to have the wind. We want to produce, a windy city, and then that each developer, each particular unit will control the wind to make it manageable, whether to have it, the comfort conditions or the safety is considered. Otherwise, we want to have, the wind available to serve, the natural ventilation if it's required. Somebody wants to design to make it available. And also, what we have, in the previous presentation, what we have seen is that the distribution of the pressure is very important in the ventilation system, what we are going to have. So how we are going to design our city plays in the distribution of pressure, what will be available in each towers. So to have a very good distribution on the faces of our towers, we have to make sure that we have enough circulation around the buildings. We have studied also using, numerical CFD. What you are seeing here is, two different configurations. Okay. What we want is to promote the wind which is coming from the northwest, the sea breeze, which we have seen. And we don't want, most of the land breeze which is coming from the south to go to the city and to have more of the circulation which is coming from the northwest. So opening the city to the northwest, having the high-rise towers locating it on the south side. So in here, in this configuration, you can see that this is the northwest direction. So it's open. We have a lot of low-rise towers, and we are putting, the high-rise towers on this direction, so that the wind will have, a propagation in this direction. When I was saying that the block of land, when it's this block, the axis is bigger. So if you have, a channeling flow in this direction, then you are blocking a lot. But if the channeling is from this direction, it's fine. So which way you are orienting each block becomes important. In this configuration, what we will see is the high-rise towers at the middle and at the back, and the northwest is from this direction. So whatever is coming from here is blocked by this one, and we'll have, less air, movement on this direction. So there's less pollution dispersion in those regions. So the parallel flow, the wind is coming from this. You can see that this region is high wind magnitude, but it becomes less on these areas. When the wind is oblique, in this case, the wind is coming from that direction, you can see that the magnitude all over is not, high, but you will have, a good magnitude in all directions, as well as in this and in this direction. Wow. Okay. The street width is important. We have two towers which is very far apart, then the interaction of the flow around them become less. But when we have, the streets which is like this, then there will be a wake flow, and whatever we have here can propagate itself. But when we have a narrow street, then whatever we have here will be recirculating here. We are forming, a dead zone. We don't want to have this one. But the decision in microclimate is not that simple, because what we are looking is not only wind. We are looking, a lot of things, how the temperature is going to be. This is what we did in the wind tunnel, comparing, the wind speed for different street widths. Well, when we have, the towers, we have to have, enough space separating them so that a lot of air movement is available in each locations. And if we have, a dust, like, it looks like, it's all dust around. So we want to have some blocking if it's south direction so that it will be suspended, the dust all over, over the area which we don't want it to be. Heat island effect, it's formed because of the composition of what we have in a city. It is covered by the buildings and the roads. All those changes, the characteristics. And also the human activity also produces heat. And all together makes the heat island effect. What kind of material which we use will also determines how less we can reduce the temperature. This is a picture which I have, the plot, which shows the trend in Dubai, the temperature. From 1984 to 2005, it shows an increase of 2 degrees centigrade. But this is not, I don't believe this is because of the change, the general change in the climate, but the change in the material what they are using and the urbanization process has contributed a lot, but there is a lot of up and downs which we are seeing. And there is, a temperature increase. Each temperature increase requires us, a lot of cooling demands, and any decrease in 1 degree centigrade corresponds to a reduction in cooling demands. We have studied the shades. In particular, this one is each configuration where we have, the towers and on the podium, which one will give us, the best solution. And we have studied, a different configuration of the shadow. And the last one is we have, used infrared rays. What is the use, the advantage of vegetations? And this is in Dubai, which shows that trees at 42 degrees centigrade and pavement at 56 degrees centigrade at the daytime, and the reverse happened. So if we have, vegetation along the street, then we have a big temperature difference that helps us, to reduce, the heat island effect in our cities. In conclusion, I'll say up to 9 months in a year, it can be okay, like a city in Dubai. And the transition months from shoulder months from moderate to high temperature region also can be improved. We have to look, adaptive kind of comfort. We have to promote a sea breeze in the city. Progressive height is important. Shading vegetation is important for our city. Shukran.